So the next section is about what's called the law of sines. The law of sines is a tool that we can use to find sides of triangles or angles within triangles as well, where it isn't necessarily a right triangle. You don't need the right triangle to be right. So it could work no matter what. If we have, well, not no matter what necessarily, but A, big A, little b, big B, big C, and little c. Right, so it's always the same setup. It's kind of standard. Then this relationship here is true. These fractions are all equal to each other. All right? And the thing is, it looks like a lot, but really we only use two at a time. So we might only use the A fraction and the B and the C fraction. Or we might only use the B and the C. So we only use one at a time, one pair at a time, so two of the three. So it's always like solving proportions in terms of what you have to do. All right? If you have two angles and a side, then it's perfect. It will always work. There are times when you have two sides and one angle, and you could use law of sines, but sometimes that's a little trickier, and then we'll do that. We'll see why later. We'll do that later. All right. So let's do this one. Just one quick example. Notice the setup is exactly like the picture. Well, not the exact same picture, but how the C's are opposite of each other. The A's are opposite, and the B's, well, that's not labeled as B, but I should do that there. B is 9. Okay? Little b. Sides are lowercase. Angles are uppercase. That's just kind of a standard thing you'll see in most trig books. All right. So this is just like solving for right triangles in terms of how I want you to approach it. Write down what we're trying to figure out. So really the only unknowns are little a for the side length, little c for another side length, and big A. Okay? Now, I always recommend finding the easy thing first, get the easy stuff out of the way first, and so this isn't even law of sines. Angle A, we have 2 to 3 angles, so we could do 180, this trig here. Okay? So there you go. So that's just the geometry thing. So there we have that. Next thing we can do is we can use the law of sines with, well, either A, which is what I'll choose since I've started writing it, either A and B or, right, and what we always pick is basically we know both little b and big B, so this one's going to have to be what we're going to have to use that one, right? And then we're also going to use little c and big C and the other to find C. So little c over sine C. Okay. So notice it's basically two separate problems. One to find little a, one to find little c. We have a over the sine of 47 degrees equals b over the sine of 53 degrees. Okay? Oops, b is 9. What am I doing? B is 9. The whole point is that you should be able to set up something where there is only one unknown. All right? So 9 over sine of 53 still in there. And then here it's c over the sine of 100. Okay? You will definitely need your calculators. You'll definitely have to be in degrees. Okay? Okay, normally I said don't use the stuff you figure out Okay, and we figured out the 47. Okay, I said that a few times when we were doing right triangle solving, but here we really don't have a choice. Okay, so you have to use it. So A equals, multiply both sides by this. So we multiply both sides by the sine of 47. So it becomes 9 okay. Might as well just go straight to it here. We need the calculator. So we do 9 divided by, oops, that's wrong button, divided by 53, and we sine. Notice I'm in degrees. Okay. And times sine of 47. So this is the type of calculator that on a computer, the type of calculator the computer has you have to hit the angle first and then hit the sine button or whatever. In this case, the sine. There you go, 8.24. So A is approximately equal to 8.2. The rules for rounding are the same as when we're doing right triangles. General rule of thumb in this book is round to the nearest tenth of an angle, or tenth for a side, excuse me. Round to the nearest tenth for a side, nearest whole number for an angle, okay, or whole degree. And then really the process for C is the same. It totally mirrors. The algebra you have to do is totally mirrors it that we did for A. Multiply both sides by sine of 100 degrees. And so if you have a calculator where you see it as you type, basically you just have to make sure to use parentheses around the angle measures and you'll be fine. So you have 9 divided by sine of 53. Okay, so you would type sine of 53 there, making sure to close the parentheses around the 53. And then just do times sine of 100. All right, so it's different than what I'm doing here, but if you just make sure to type it in as it looks on your paper, as you're writing it out, it should work fine. And you get 11.1 for C. 11.09. And there you go. These aren't necessarily drawn to scale here, but I feel like the book's pretty good about making the side lengths look reasonable. And always do a check for reasonableness with really any math problem, but it's easy here. The biggest side should be across from the biggest angle, and that is the case here. Right? The smallest side should be across the smallest angle, and that's the case here. So at least from that perspective, there's nothing that's obviously got to be wrong. And I mean, I'm the teacher. I hope I just did that right. It should be right. All right, so there you go. That's law of sines. The problems you guys are going to have to do tomorrow in class are like that.